But first of all, I would like to give you a warm welcome to our talk about automating incident response. We're going to talk a little bit about how we look at incident response and how you can do it scalable and fast within minutes. But the subtitle probably already gave that away.
My name is Zawadi Donné. I'm an incident responder at Hunt & Hackett. I have a background in DevOps and incident response, and I've worked as a cybersecurity consultant, DevOps engineer, and as a developer. And you?
My name is Matt, or for the Dutch-speaking Matthijs, but I understand that that's not a really usual name. So my name is Matt Dijkstra. I work at as an incident handler. Been doing this work for almost a decade now. I have a background in criminology and crisis management. And if you scan the QR code, you can link up with us directly through LinkedIn. We've got some remarks to start off with as well. Rest assured, we're definitely not going to talk about artificial intelligence. Although we can neither confirm nor deny that ChatGPT has been used to create the content of these slides. So what are we going to talk about then? Well, about us incident responders. We are special, we are unique, and we are good, if not the best. Our capabilities might not be required for every situation, but when the need is high enough, you can call us and we'll be there. We'll get there fast and we get the job done. We cannot be easily replaced, and sometimes we can even be a little high maintenance. But are we really this super unique, cool concept car that not everyone needs or can afford? Or are we actually just a mechanic? Are we this guy, maybe this guy, or this guy, who are specifically tasked to fix something that broke? We are responsible for a part of the entire engine or the machine. We're not responsible for the design, strategy, or the way it looks. We just need to find and fix what we are tasked to do, which more often than not is find the attacker, kick them out. That is our task, and we do it well. Sure, we create innovative solutions to the tasks right before us, but is that really the innovation we need? We probably all had engagements where hundreds or maybe even thousands of systems needed to be acquired, needed to be secured and processed manually. And even the steps investigating those machines were probably also to a large extent manual. And we all work with clients where, of course, we need to assume incompetence because why else are we here? No, I'm kidding. It's just that forensic acquisition for the organizations that we help is not part of their day-to-day business. So we need to explain it to them, what's going to happen, what we're going to do, because it is part of our day-to-day business. So therefore, what we want is to make it easier. We want to make doing our work easier for us, and we want to make it easier for the clients we help. And most importantly, as foolproof and automatic as possible. So what is a problem we are trying to fix? Well, the traditional approach rooted in and originating from digital forensics is just no longer sufficient, because the frequency and scale of incidents is just increasing to a very large extent. And CERT teams all over the world, they face significant challenges with managing these security incidents. So the traditional approach, where large amounts of data needed to be acquired over several days before you could initiate an investigation, it's just not efficient enough anymore. It doesn't help you to deal with large-scale enterprise compromises. And also, nobody really wants to perform processing and analysis by hand over and over and over again. During each incident response case, reinvent the wheel over and over again, and work in the traditional, forensic analysis way, which was more rooted in the, hey, man, can you pass me that Excel sheet, please? It was more single person focused, and it doesn't really scale that well. So this is partly because, as we observed, there was a lack of strategic innovation. So this is what we call the perverse incentive. The lack of strategic innovation is rooted because more billable hours meant bigger profits for organizations, and innovation also costs time. So why, as an organization, would you invest in innovation if it ultimately results in you being able to bill less hours? So there's no real incentive to do that. And that's what we call the perverse incentive. The problem here is that, well, innovation is done by you guys on specific cases, innovating on specific tasks, but that's more short term. You create scripts or plugins or parsers, but tactical long-term innovation wasn't really part of incident response. So we want to find attacker traces and not think about development life cycles or development processes altogether. But the DevOps mindset is what we believe is lacking. It has not been standard part of the IR toolkit until now. So we definitely need to keep innovating for technical tasks at hand, but we also need to make sure that we bring that innovative mindset. We need to bring that into the business to move the industry forward and remove that perverse incentive action. So to realize that, we want to bring DevOps into incident response, which means strategic innovation. So you want to have a strategy for your innovation. How can you make sure that you are still working as efficiently and effectively as possible in 5 years from now? Where do you want to be? What needs to be done? You want to work towards that. On every case, improve just a little bit. And based on feedback from my R cases, you want to adapt, improvise, and overcome. So you prevent that you get into whack-a-mole situations, only solving ad hoc problems. You want to ensure your methods in the way you conduct your investigation or go about incident response is repeatable. You want to take that extra time to make things sustainable. So not just write a quick solution for the problem right before you, but make sure it can be used again. We want checks, tagging, labeling to also work for the next case and the case after that and the case after that. So you want to leverage automations to ensure consistency and reliability in the incident response processes and tools. And this, as a side benefit, also reduces human error, just as feedback loops do. You want to gather insights from incident response cases and use these to identify issues and create reusable parsers and improve based on the feedback from the initial results. So then you can validate assumptions, and in doing so, see if the tools produce what you expect, and well, in that way, if they are efficient or not, and make your life easier. This is the fourth one, you want to validate your input. I mean, it's nice that you gather all this information, it's all this investigation data, but how do you know that the tools you sent out to collect your investigation material, how do you know that they actually collected what you are expecting to see or what you need in your investigation? So you want to ensure that the software and the processes, that they fulfill the requirements of the team, but also of the client through your development lifecycle. You want to do that by validating if your automations are working and if they ensure the reproducibility of the findings you have throughout your incident response process. And finally, we need to embrace the DevOps mindset to enable cross-team collaboration. You want to break down the traditional silos. You do IR, you do Intel, you do SOC. No, you want to foster collaboration between incident responders, reverse engineers, threat intelligence, analysts, red teamers, SOC analysts. You want to make sure that the information can flow back and forth, insights can be shared, and that cross-team collaboration makes all of our lives easier. Because this integration should extend beyond our internal team collaboration and extend to collaboration with preferably even the client's incident response team, so they can start tagging and they can collaborate and even participate in the investigation.
So, thank you, Matthijs, for explaining the DevOps mindset. Now we will start talking about how we built an incident response lab and based on the key principles that we have founded. So in setting up our cloud-native incident response service, we had the benefit that we could start from scratch. And based on previous experience, and because we live in a cloud-native world, we built a lab based on certain key principles. By building reliable services that work independently from each other, that are available anywhere across the globe, which can be scaled based on the demands of an incident response case. This means that if the if the incident response case contains hundreds of systems, that the lab should be able to scale to that amount of systems. And next to that, the lab should support different kinds of data sources and tools in an agnostic manner. In addition, the lab should consist of segregated environments for different investigations, ensuring that data and operations are contained and cannot interfere with each other. And at last, ensure that environments can be governed and deleted in a GDPR compliant manner, respecting legal requirements. As we believe that a tool alone is not the solution, you need a strategy that can be applied across multiple tools. In the last couple of years in this community, we have observed the release of new incident response tools. And as mentioned, one of our key principles is to be agnostic, which is a result that we don't believe that a single tool can fix all your problems. And because of that, you need a strategy. A strategy is needed, which can be applied across multiple tools. Because in the end, you don't want to have an incident response kit that only contains a hammer, because there are situations where a hammer is not the proper tool to solve the problems you face as an incident responder. We even encountered problems ourselves when building our lab. So we'll talk about the foundation. 2 years ago, I built an incident response lab as shown in the diagram. As shown in the top left corner, Velociraptor clients that upload forensic packages to the lab, which are then automatically processed to a timeline of events with Plaso, which has parsers for forensic artifacts and logs. After which these timelines can be investigated with Timesketch, which is a collaborative analysis platform. This project is open source and available on GitHub. And using this project, any incident responder can use the lab for incidents with around 20 systems. But that was not enough for us, because we needed a solution that can be scaled based on the demands of an incident response case. 20 systems is not enough for an incident response case with hundreds of systems or even thousands of systems. So during the last 2 years, we leveraged this project for the foundation of our new incident response lab, which looks like this: a cloud-based incident response lab that uses various acquisition, processing, and analysis methods, which can be used to perform incident response in a scalable manner by collecting a variety of data sources as shown on the left, by using, for example, Velociraptor, and as shown in the middle, these data sources can automatically be processed with Dissect and Logstash to a timeline of events. These timelines can then be analyzed using Timesketch and Jupyter Notebooks, and by leveraging repeatable automations, this allows us to ensure consistency and reliability in the processes and tools of the lab. And now you'll be asking, how did we build this? We are a huge fan of setting up infrastructure using infrastructure as code, with tools like Packer, Terraform, and Vault. And infrastructure as code is managing and provisioning of infrastructure using code instead of using manual processes, which enables us to feed the knowledge gathered from incident response cases into playbooks, configurations, and other repeatable methods that can be reused during new incident response cases. And by provisioning the lab via automation, we ensure consistency, reliability, and repeatability, which allows us to streamline data acquisition, processing, and analysis with only 5 lines of code as shown on the left. With only these 5 lines of code, we can set up a lab as shown in the previous diagram. So how does it work, Matthijs?
Nice. Well, here's an example. You have a customer environment, and this customer environment consists of laptops, desktops. There's probably a data center somewhere that hosts some infrastructure. It all connects in and out over super securely configured firewalls. There's probably a little bit of cloud infrastructure in there as well. And there are probably some remote systems that connect either through or to the cloud infrastructure. And then on one unfortunate day, systems within this environment become compromised. One way or another, an attacker gains access to these systems, as they ultimately always do. And then what needs to happen? Well, We use various software packages, of which Velociraptor is one, but for instance, also SharpHound is used, or SharpHound to collect. And we create forensic packages or gather Active Directory objects from within the compromised domain. We want to get that material to our incident response lab, but we don't want to do that manually because that's horrible. So the entire flow is automated, from acquisition to upload and processing, all the way into putting it into timelines that are ready for analysis, but we're going to save a little bit for the demo. Then manual analysis can start by the analyst that is investigating this case. So although we are currently looking at automating part of the analysis track as well, because we want to enable some automated detection based on cyber threat intel. So how do we do this then? Well, we will now discuss 3 crucial ways of data acquisition, being the acquisition of memory, being the acquisition of virtual system through a hypervisor, but also using Velociraptor. So there are actually two capabilities of Velociraptor. One is the data acquisition. First, let me start. Can't really see if you understand what I mean when I talk about Velociraptor. So let me take one step back and first explain what Velociraptor is. It's an open source digital forensics tool. And you can use it to perform targeted collection of artifacts and collect various logs across different systems. And that's the way we primarily use it as well. We use it as a data acquisition tool to create forensic packages and send them to our lab. Although it can also be used for hunting and monitoring. We use Velociraptor to automatically collect forensic packages from Windows, Unix, macOS, and we upload them to our Google Cloud storage. That process alone is very, very fast and very scalable because you can automate that as well. And Google Cloud Storage Platform, it supports unlimited storage, basically. So why do we use Velociraptor? Well, because it's fast and it's reliable.
So we've talked about Velociraptor, but we also want to mention something about the underestimated value of memory. So besides implementing automation at scale, we are also interested in innovative subjects that improve our incident response capabilities. For example, a system consists of more than a file system. The memory of a system is just as crucial to get an overview of activity that has taken place on the system. And in addition, advanced persistent threats have been utilizing memory to subvert investigations by employing techniques like anti-forensic, fileless threats, and kernel rootkits, which often leave no traces on a file system. And we believe that the incident response community should, in response to these threats, broaden data acquisition beyond the file system and to include the acquisition of memory. Because this multi-source data collection approach offers a comprehensive view of system activity and reduces the risk of missing crucial traces during investigations. But what about virtual machines? So the methods we have described thus far involve actions that could alert an advanced persistent threat of incident response activities. If we execute Velociraptor on the system, it could be detected by an APT that is also active on the system, which looks like this. As shown on the right, the infrastructure consists of virtual machines that are managed by a hypervisor. The APT conducts malicious activity involving various tactics by achieving initial access after risk persistence is established by setting up a command and control channel, followed by lateral movement to gain access to certain machines until the goal of the APT is achieved. And while this is happening, the incident response team is executing software like Velociraptor on these machines to perform data acquisition. But this can be detected by the APT, which could further escalate the incident. And because of that, it might be preferred to remain unnoticed for as long as possible. To prevent this from happening, it can be crucial to conduct undetectable data acquisition, ensuring that the APT remains unaware of any incident response activities. The tool Acquire, part of the Dissect incident response framework, can solve this problem by covertly performing data acquisition from a VMware ASXE hypervisor, as shown on the right. And we believe that this should extend collecting data from virtual machines from a file system, but should also include acquisition of memory from a hypervisor. And as mentioned, the tool Acquire enables us to perform undetectable data acquisition, which allows us to track an APT in real time, while the APT remains unaware of the investigation. And this allows us to perform data acquisition without being detected, and could also improve the remediation phase of the incident, because you can feed findings from the investigation to that phase and then remediate the APT from the environment. So we have talked about various innovative subjects, but one recurring theme is the repetitive nature of work during incident response cases. This often begins with the observation of logs that could be crucial to the investigation. You, for example, have a Linux system with logs in the var log folder, and these logs are then manually searched for matching patterns, which results in unstructured data. In addition, this method is not repeatable and does not ensure consistency and reliability, which leads to unstructured analysis that is not repeatable in an automated manner. But we as an industry can do better, right? Instead, we should create parsers for data sources that can transform it to a structured data format. In addition, if new insights are gathered, the parsers can be improved and encountered bugs can be fixed. This eventually leads to structured analysis and a happy analyst that can secure the knowledge gathered from incident response cases. In such manner, we leverage feedback loops to feed the knowledge into parsers, playbooks, and other repeatable methods. This ensures that our knowledge is secured and that parsers can be reused during new incident response cases, as shown in the diagram.
All right. Nice theory and all. Talked a lot about how it should work, but maybe can you show us a little bit about how it works in practice?
Yeah, we can. We'll show you a demonstration of our own incident response lab that we use during incident response cases. As mentioned and as shown in the slides, this is our processing platform. And on the left, you have a customer environment, and on the right, you have a processing platform. So let's start. We have an incident response case that has just started and is shown in the top left corner. And explained, the case starts with a compromised customer environment as shown on the left. It consists of several data sources, but in this case, we want to collect forensic artifacts and logs into forensic packages of 25 Windows systems using Velociraptor. And after which these packages can be processed in the lab as shown in the middle as part of the processing platform. So we're now 20 minutes later during the case, and we have collected the forensic packages of 25 Windows systems. As mentioned, Google Cloud supports unlimited data storage, and because of that, we don't have to worry about the storage size of these packages. 10 minutes later, and in the meantime, the processing platform has started a virtual machine for every package that starts the processing of the collected forensic artifacts and logs to a timeline of events using the Dissect incident response framework. And as shown in the top left corner, we just have been busy for only 40 minutes. And all the actions that have been executed as shown in the slides were all done automatically. The packages have been processed by the processing platform as shown in the middle. And now we can start with analyzing the timeline of events using the analysis methods as shown on the right. With manual forensic analysis using Timesketch, and automated forensic analysis using Jupyter Notebooks, after which the findings of that can be reported to the customer. So the analysis starts with checking the overview of timelines in Timesketch, which shows which systems have been collected and which timelines have been created. In this case, Timesketch contains more than 200 million events of various forensic artifacts and logs. And by leveraging our analysis platform, we can use the Kibana query language to query, to search for traces of compromise using various data types. And as shown in the image, the Windows event log provider Sysmon has been used to search for traces for the execution of Velociraptor. This was all done within 1 hour without executing any manual processes. As shown during the demonstration, the lab allows us to do incident response, but then scalable and fast within minutes. And as shown in the slide, analysis has just started within 1 hour of 25 Windows systems. And we want to make you aware that everything we have just explained wasn't possible without the open source incident response tools that we use to perform data acquisition, as shown on the left, the processing of investigation material, as shown in the middle, and as last on the right, the tools we use to perform forensic analysis. At Hunt and Hackett, we are huge fans of using open source software as part of our lab. And leveraging open source software offers several benefits, including the ability to view and understand the source code and collaborate with other incident responders in the community, which you are a part of. And therefore, we would like to thank everyone that has contributed to these tools. So, takeaways.
The takeaways. Finally, we're almost there. What do we hope you take away from our demonstration and the way we look at incident response and incorporating a DevOps mindset? Well, automation completely eliminates startup time of the investigation. So this really facilitates scalable and fast forensics. Zawadi has shown how fast it can work for 25 systems. Doesn't matter whether it's 25, 250, or 2,500 systems. You're only limited by the capacity of the cloud. Automated processing and tagging, it really helps accelerate detection based on indicators of compromise, especially if you build repeatable methods. So from a previous case that you can use on the next one as well. I mean, you don't have to rebuild, retag everything. You can automate that. And you can give it labels on suspicious, good, or known bad. And that really makes it analysis, even a manual part of analysis, a lot faster and easier to investigate a lot of machines simultaneously. And you can reduce the margin for error as well. The automated acquisition and processing, therefore, also helps to contain incidents faster. You can do more incidents simultaneously. The beginning of this year, we've done 6 cases at the same time with just the 2 of us. And well, it can only happen because a lot of the process is automated and because of the speed of it, the speed with which it works. So really helps you contain incidents fast. You can do more incidents simultaneously, and you can reuse forensic analysis steps. And not only can you contain incidents faster, the incident is wrapped up faster as well. So you can go on to the next one, especially if you get to the automated detection part as well, where you can feed threat intelligence, SOC knowledge, detection logic, and information from old incident response cases into the new ones. By working together in that way, cross-platform, this facilitates easier reporting over root cause, which is a big win. So to conclude, we strongly believe that when you incorporate a DevOps mindset into an incident response strategy, it becomes possible to resolve more simultaneous cases, resolve them faster, and do it with less margin for, let's say, human error. Scalable and repeatable investigation steps in automated detection will make your life easier. Why do I know this? Well, because it made our lives a whole lot easier. And in doing that, IR even became a lot more fun. That is why we believe in the strong connection between DevOps and digital forensics. We would like to thank you for your time. We can't see if there are any questions or raised hands, or if you're all throwing your drinks in the air, applauding, or if you have any questions, just reach out to us. You'll get to a page where you can find us online and ask any questions, or use the Slack channel, which also works. Yeah.